Go, 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 go. Go, membranes, it's your work day. We're selectively permeable like it's your work day. We gonna kick out the harmful stuff on your work day. But the need is something to get through passively and actively. We in the club controlling the cell membrane. Molecules like oxygen and water can pass them freely. This is called diffusion from high to low concentration. The diffusion of water has specific terms called osmosis. For example, with salt water versus pure water, the water will tend to move toward the salt. Hypertonic is when there's a higher concentration inside. Hypotonic, higher concentration outside. When the solution is isotonic, both the concentration gradients are equal. Non-polar molecules such as oxygen pass through the membrane, but water can't pass through the cell membrane since it's possible that biolayers have hydrophobic tails, meaning that they hate water. That's why there's a specific channel protein only water and ions through. The organ parts can let 3 billion molecules a second. That's an example of passive transfer from high to low concentration. And the good thing is that it doesn't require energy. But the molecules need to move from lower to higher concentration. That is when active transfer comes into play. It requires energy, specifically in the form of a density triphosphate. One example is the sodium potassium pump discovered at Jens Squirt. You want to know how anesthetics worked on membranes, but the pump was discovered out of a crab nerve cell. To verify the find, he experimented with 25,000 more, and he won the Nobel Prize 40 years later. We in the club controlling the cell membrane. Molecules like sodium and potassium need ATP to pass through. This is called counter-diffusion from low to high concentration. An example can be the sodium-potassium pump. It requires 1 phosphate from ATP. That allows the pump to allow 3 sodium ions. The pump can work 1 more time so it lets in 2 potassium ions. This is extremely important for muscle and brain cells. Every cell has an electrochemical gradient. In the cell, it is negative, while out the cell, it's positive. But if you're confused on what ATP is, it stands for adenosine triphosphate. It has adenine and the ribose sugar, and the triphosphate stand for 3 of them. To release energy, an enzyme shoots a phosphate up. The more phosphates it has, the more energy it releases. When enough potassium ions get out of the nerve cell, it has so much energy to make you have the 5 senses. But that's not it, as there is vesicular transport. They're made of phospholipids like the cell membrane. Anytime they get involved, it is called cytosis. Endocytosis is getting in the cell, while exocytosis is the opposite of that. We in the club controlling the cell membrane. Viruses need to be killed with phagocytosis, while solutes and liquids need to get inside with pinocytosis. But what if small quantities need to get in the cell? There come the clusters to the rescue. They use the receptor proteins to detect the molecules they're looking for. This can help maintain cholesterol with receptor-mediated endocytosis. Don't try to act like this information is useless, everyone. In the club, 24/7. Rarely get cell malfunction, everyone. Sponsored in part by Cell Unit.